Questions 5 through 10 on the 2019 Grade 12 Euclid Math Contest. Determine the two pairs of positive integers ab with a less than b that satisfy the equation root a plus root b is equal to 50. Root a plus root b is equal to 50. So how do we do this? Do we use inspection? Interesting question. Well, I'm going to isolate for one and see what happens. So root b will be root 50 minus root a. Okay. Then I'm going to square both sides. That will just become b. And when I square this, it'll become 50 minus 2 root 50 root a plus a. And then that is, this root 50 is what? 25 times 2. So that's 5 times root 2. So that's going to be 10 root 2 root a plus a. Okay. At this point, I'm going to stop and talk about this. They're telling me that both a and b are integers, right? So if b is an integer, then this whole side must become an integer. That's an integer, a is an integer. Those are not a problem. But this has to be an integer. So we're going to concentrate just on that. We have to make that an integer. Well, how do I do that? Well, one obvious way is if a was 2. If a was 2, then you'd have a root 2 times a root 2, and that would be 2. So let's see what happens when a is 2. When a is 2, I get the following. B is equal to 50 minus 10 root 2 plus 2. B is equal to 50, 2 times 10 minus 20 plus 2. So b is equal to what looks like 32. Okay, well, there's one of the pairs that they're looking for. 2 and 32. So they have said there's 2, so I only have to find one more. Okay, that strategy worked. I'm going to keep that strategy going. So last time I chose 2. What else can I do to make that an integer? How about root 8? That would work. So a would be 8, right? If a is 8, then that root a would become root 8, which is also 2 root 2. So I'm really just trying to get rid of that root 2 or change that root 2 into an integer. Okay, let's see. This looks promising. Let's see what happens. B is equal to 50 minus 10 root 2, root a, which is 2 root 2, and then plus a. So I've got 50 and then 20 times 2, so 40, and then plus a, which is 8. So that's 10 plus 8, 18. All right, I got another one. So what was it? 8 and 18. And there you go. So, interesting question, actually. I was a bit unsure as to where to go with this, but this strategy definitely helps. Consider the system of equations. C plus d is 2000, c over d is k. Determine the number of integers k with k greater than or equal to 0, for which there is at least one pair of integers cd that is a solution to the system. C plus d is equal to 2000, and c over d is equal to k. Well, c therefore equals d times k. Sub that back into here, and we get dk plus d is equal to 2000. Factor out the d and I get k plus 1. And that is equal to 2000. So that means k plus 1 is equal to 2000 over d. Well, they're telling me that k is an integer. So the only way k plus 1 will be an integer is if d is some divisor of 2000. For example, if d was equal to 5, then you'd have k plus 1 is equal to 2000 over 5. And as we all know, 2000 over 5, actually maybe I don't know, is 400, I hope. And therefore k would be 399, right? So that's just an example. So d has to be a divisor of 2000. Okay, well, how many divisors are there of 2000? Well, 2000, first break it up into its prime factors. It's 2 to the power of 4 times 5 to the power of 3. And I'm sure you know this, that the number of divisors, once it's broken up into its prime factors like that, you can figure out the number of divisors very easily. You take the first exponent, in this case it's 4, and you add 1. And then you multiply that by taking the second exponent and then adding 1. So in this case, that's 5 times 4, so that's 20. So that means there's 20 divisors of 2000. And for each divisor, we will get an integer solution for k plus 1. And therefore, we will get an integer solution for k. So, in conclusion, k has 20 integer values. And this question has a little symbol that represents that you have to write out full solution. So, as always, try to be as complete as possible. Everything that I just said, that there's 20 divisors of 2000. So for each divisor of 2000, you will get one solution for k plus 1. And therefore, you'll get 20 solutions for k plus 1. And therefore, you'll have 20 solutions for k, which is pretty much what I wrote. But you can be a little bit more elaborate in your solution. A regular pentagon covers part of another regular polygon as shown. This regular polygon has n sides, 5 of which are completely or partially visible. In the diagram, the sum of the measures of the angles marked A and B is 88. Determine the value of n. So we've got a relatively challenging question, I think. And the question here is, where do we proceed? How do we proceed? Well, I'm going to draw a line from this point right here where that polygon touches all the way to the other side like that. And that will help me, I hope. And I'm going to label this segment or that angle right here, I'll just call it Y. And then this guy here, I'll just call it Z for now. Now this one I know, it's a pentagon. And even if you didn't know, you can figure it out pretty easily. A pentagon is essentially 3 triangles, right? So each triangle has a sum of 180 in terms of its angles. And then there's 1, 2, 3, 4, 5 internal angles. And it's a regular pentagon, so all the angles are the same. So each would be calculated by dividing by 5. So this is really just 540 divided by 5, which is 108. So each of those internal angles is 108. So this angle in here is 108. So right off the bat from that triangle, you can conclude that 108 plus z plus y is equal to 180, and therefore y plus z is equal to 72. Okay, so 72, where do we go from here? Now, I think I can just concentrate on that segment there, this part. And I'm going to cut it into triangles. So try to do this accurately. Here's one. Here is another one to that point. And here's another one to that point. So as you can see, I created 4 triangles, right? 1, 2, 3, 4. Here's the first one. Here is the second one. And here is the third one. And here is the fourth one. So the sum of the angles of those 4 must equal 4 times 180. Now I've got to figure out what to write in terms of the angles. Now, the good news is that they gave us a regular polygon. And as they state in the question, all the angles are equal. All the internal angles. So this guy, this guy, this guy, and this guy, those are all equal. So I'll just call those x. So x, 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 and x, like that. Okay, I think I have them all. All of those angles in those 4 triangles, if you add them all up, starting with y plus a plus those 4 x's plus the b and the z. I'm confident that's it. Yeah, that's it. So, okay, I think we can go with this here. So 4 times 180 is what, 720? And then we have y plus z. I'll group those together. Then I have a plus b. I'll group those together, and we have a 4x. Well, the good news is y plus z we already figured out was 72. And a plus b they gave us is equal to 88, the sum. So that's great. So 4x, 720. All right, great progress. So now we can substitute, or solve, I should say, not substitute. So 560, when you put all the numbers on one side, is equal to 4x, and therefore x would be 560 divided by 4, which is 140. Okay, great. So the internal angles of that polygon is 140, and they wanted me to figure out the value of n, which is representing the number of sides. Okay, that's cool. Okay, so I gotta give some of you know this formula, some of you don't, but I'm gonna walk you through it. If you didn't know the formula of how to figure out the internal angles of a polygon, I did a little bit right there. So I'll do a little bit of an extrapolation just to fully illustrate the formula. So if you have, this was a 5-sided, right? Let's say I had a 6-sided regular polygon. So definitely not drawn to scale, but you guys get the idea. And it is 6 sides and it's 4 triangles, right? So the sum of its interior angles must be equal to 4 times 180. And then if I want the measure of each interior angle, I'll divide by how many interior angles there are. In this case, 1, 2, 3, 4, 5, 6. So that's how it would be. This was for the pentagon. This was for the hexagon. I think that's what it's called. So as you can probably deduce, it just kind of is a very similar formula. In general, if you have n sides, it would be n minus 2 times 180 divided by n. So like I said, some of you may know this formula, some of you may not. Even if you didn't, with 1 minute of kind of thinking and extrapolation, you can get that formula. Well, why is this useful? Well, because we know the answer to that. We know it equals 140. So all we have to do now is make that equal to 140, and we are set. So n minus 2 times 180 over n is equal to 140. So that means n minus 2 over n is equal to 140 over 180, and that is 7 over 9. And at this point, you can probably do this by inspection. What n is, I think I can. N is 9. Or if you can't do it by inspection, you can cross multiply and do it that way. But in either case, you'll get n is equal to n. So n is how many sides? So there are 9 sides to that regular polygon. In trapezoid ABCD, BC is parallel to AD and BC is perpendicular to AB. Also, the lengths of AD and AB and BC in that order form a geometric sequence. Prove that AC is perpendicular to BC. This is geometric, not arithmetic. Because if you go in the arithmetic direction, you're not going to be able to solve this question. I just want to emphasize that. So here we go. Arithmetic sequences are of the form A, then AR, then AR squared, and then so on. AR to the power of 3, and it goes on from there. So they told me that the lengths are of that form. So AD is A, and AB would be, I guess, AR, and then the longest one, BC, would be AR squared. Now what I'm going to do is put it on a coordinate axis, because it really, really screams that to me. It's almost like it's telling me to do that. And off we go. So before I begin, what is the goal in this question? We have to prove that AC is perpendicular to BD. Here's AC, and here's BD. How do you prove that two lines are perpendicular? Well, their slopes will be negative reciprocals. So if one has a slope m, the other would have a slope of negative 1 over m. Or another way, which is pretty much the same thing, is if you multiply the slopes together, their product would be negative 1, as the m's cancel. So either way, you'll be able to prove that the two lines are perpendicular. So that's what I'm going to do. Okay, so let's label this now. B is obviously at the origin, so that's 0, 0. C is AR squared for the y coordinate, the x coordinate, and the y coordinate is 0. D, it looks like the x coordinate is A and the y coordinate is AR. And then A over here, the x coordinate is 0 and the y coordinate is AR. Okay, I can easily figure out the slopes now. So the slope of AC, using rise over run, as I'm sure you guys remember. So that would be rise over run. Where's AC? Okay, going down here. So 0 minus AR, and then the run is AR squared minus 0. So that's just negative AR over AR squared, and that looks like negative 1 over R. Slope of, what's the other one? BD. BD is this line right there. So again, rise over run. So AR minus 0 over A minus 0. So that's AR over A, and that's just R. So immediately we've just shown that they're negative reciprocals. But let's just, be more thorough. The product of the slopes, so product of slopes is, of course, R times negative 1 over R. R's cancel, and you get negative 1. So put in some sentences to explain what you're doing, and that should make the solution complete. And that definitely proves that AC and BD are perpendicular to each other. Determine all real numbers x for which 2 log of x minus 1 to the base 2 is equal to 1 minus log of x plus 2 to the base 2. So let's start here. We got 2 log x minus 1 to the base 2 is equal to 1 minus the log of x plus 2 to the base 2. So we have 1 is equal to the log of x minus 1 squared to the base 2, and then bring that over log of x plus 2 to the base 2. Now there's a lot of log rules here, and I'm sure you know all the log rules. You don't need me to write them all out. And if you're in grade 12, you should definitely know all the log rules. Now you use another one of those log rules to combine these guys, and it becomes x minus 1 squared times x plus 2, and of course don't forget the base 2. Now 2 to the power of 1 is equal to x minus 1 squared times x plus 2, and then we are going to expand this out. So when I expand it, I get x squared minus 2x plus 1, and then we have an x plus 2 in there. So this is going to be an x to the power of 3 plus 2x minus plus 2x squared minus 2x squared minus 4x plus x plus 2. This becomes x to the power of 3 minus just 3x. Everything else cancels. Factor out the x, and I get x minus x squared minus 3. Okay, so that means x is either equal to 0 or x squared is equal to 3, which gives me x is equal to plus or minus root 3. Okay, with log questions, with any question really, you should verify. And when you verify, by plugging these values back into here, you'll notice something interesting, that x equals 0 is inadmissible, because when you substitute that in, you get the log of negative 1. You can't take the log of a negative number. So inadmissible, if that's how you spell it. And the same thing holds true for x equals negative root 3. So the only solution that is valid is the positive one, x equals positive root 3. So number 7, x is root 3, and that is the only solution. Consider the function f at x is equal to x squared minus 2x. Determine all real numbers x that satisfy f at x is equal to 3. Okay, so there's a long way that leads to nowhere, and then there's the shortcut, and of course I'm going to show you the shortcut. So this f at f at x, like that. All right, so this guy in here, I'm just going to call a. So that just leaves me with f at a is equal to 3. And I can use that formula. So that means that a squared minus 2a is equal to 3. So put everything on one side, and when you do, you can easily put it into that format and factor it. A 3, 1, minus plus, right? So that means a is equal to 3 or negative 1. So what did I just figure out there? I figured out that f at x is equal to either 3 or negative 1. Okay, so now what I'll do is I'll let this guy be something, call it b. So f at b is equal to 3, or f at b is equal to negative 1. So let's go with this one first. That, using this formula again, b squared minus 2b is equal to 3. So b squared minus 2b minus 3 is equal to 0. So factor this, and we got b, 3, 1. It's the same thing, right? Yeah, so minus plus. So that means b is equal to 3 or negative 1. Great. Let's do the same thing here. So we've got b squared minus 2b is equal to negative 1. So b squared minus 2b plus 1 is equal to 0. So again, factor that, and it would give me b, 1, 1, negative, negative. So b is 1, positive 1. All right. So now I've got f at x, which is what b was equal to either 3, negative 1, or 1. I've got 3 values. So for each of these, I'm going to try to figure out what is x, because x is what I have to ultimately figure out. Okay, so let's start with the first one, 3. X squared minus 2x is equal to 3. So x squared minus 2x minus 3 is equal to 0. Therefore, we can factor this. We've done this. This is the third time now. So 3, 1, negative, plus. So x is equal to 3 or negative 1. Now let's look at that one, where f at x is equal to negative 1. So that would mean x squared minus 2x is equal to negative 1. So x squared minus 2x plus 1 is equal to 0. Factor that, and that gives me x, 1, 1, negative, negative, x is equal to 1. And then now we use that one, 1. X squared minus 2x is now equal to 1, so x squared minus 2x minus 1 is equal to 0. This one I do not believe factors, so I have to use a quadratic, unfortunately. So 2 plus or minus 2 squared minus 4 times negative 1 all over 2. So that's going to be 2 plus or minus 4 plus 8, so 2 root 2 all over 2. And therefore, that gives me values of 1 plus or minus root 2. Okay, so x is either 3, negative 1, 1, 1 plus root 2, 1 minus root 2. There we go. Those are all the possible values of x that satisfy this equation.